So today we are going to be looking at the qualitative volumetric analysis of this year's exam. We have all the requirements for us on our decks here. So the first thing I'm going to do here is to fill up the acid, which is tetraoxosulfuric acid. Fill it in the burette. So I have my B, and always remember to remove your funnel to avoid error. And here in the other side of it, the nozzle of this burette must be filled up to avoid air bubble, trapping air bubbles. Another thing is that you make sure your reading is at the zero marking. Now we remove the air bubble from the burette. Then the next one is to make sure we have it at the zero. Now I think it's at zero now. Let me see. Okay. Now it's at the zero. If you look at it very well, it's at 0 point marking now. So this is where it's supposed to be. So the next thing is to come and pipette we're going to pipette the base into the conical flask. So let me do the pipetting now. This is the base, which is sodium hydroxide. Yes, we have it now. So the next thing we are going to be adding now will be the methyl orange, the indicator, which is methyl orange. Adding 2 drops. Then I shake. You can see the color now, the yellow color. So now I'm going to titrate, and then I'll use my white background to watch when there will be the exact color change. Now I note my initial is 0.0. I started from 0.0. Now the color has changed. The color has changed. So let me show you. The color has already changed. As you can see, no more yellow. So the color has changed now. So what's the reading? Our reading now is 12.1. That's 12.1. I think I need to bring the camera closer. You can see this is okay now. That's 12.1. Now it has 12.1. So this is the reading, that is 12.1. Then we're going to do another titration. Alright, that's the color, the orange color of our titration. So we're going to be doing another one. So we're going to start another one. This is another base I've already pipetted, so that this thing wasn't on before. So I'm going to add methyl orange. I'm going to add methyl orange again. I'm adding 2 drops. So we'll start our titration again. I shake, then you need to adjust your background or the white background so that you'll be able to know what is really happening when the color changes, getting closer. Now my niche here is where the last one is stored, because since I have 12.1, meaning that I can still get another 12.1 or more from here. There's no need starting from the beginning, starting from 0 again. That's the thing now. Now at this point where the color is coming and disappearing is when you have to be very, very careful in your titration, so that you'll be able to get this endpoint. The color is coming and disappearing. The color has changed again. You can see the color has changed. This is another color here. So our orange color again. Now let me take my reading. So this one is 24. Let me get this thing closer. Now I started from 12.1 and ended at what? This one ended at 24. My initial is 12.1. I need to bring this camera. You can see now it's at 24. So we are going to. So this is the outcome of our titration. So this is the readings. the final down to the end. I have to like reduce the timing so that we'll be able to do this calculation. I don't want this thing to take too long. I look at it, the timing, the time of titration has been, titration is almost taking a very long time. So I said, let me just trim it down and get this done this way. So we noticed that from our titration, the first one was 12.10. Then from this, we use it to titrate the second one and the rest of them. So here the question says, A is a solution of a diabasic acid. That's a diabasic acid. Diabasic means that hydrogen there is 2. And S. Say B is a solution containing 0.1 mole per dm cube of sodium hydroxide. From the results and information provided, calculate the concentration of A in mole per dm cube. The other one, number 2, there is a molar mass of the acid. And they're given that 250 cm cube of the solution A contain 2.5 grams of the acid. Find the volume of the third question. There said find the value of what? X. These are our balanced chemical equations. So let's quickly look at it and find out what we are going to get from here. So the first one we're going to do here is that we need to calculate the average volume of the A used. The average volume, if you look at this very well, all the values seems to be together. The range is always the same, almost the same. This one and here is about 0.2. This one and that, this one and that. This and yes, this is approximately 0. This one is 0.2 when you look at it. So what we do, we can use all. Using all, we entails average of what A use will then be plus 12 plus what? Another 12 all over what? 3. So let's see what we have. So the up one is 35.9 divided by 3. We have equal to 11.97 cm cube. So that is our average volume. So this average volume is what we need in calculating the other ones. Then the molar mass. Now we're giving the molar mass. How do we go about this molar mass? Let me just start it from here. So if you are writing down, I will encourage you to do that fast so that you have enough space for our work. Okay, let me see if I can clean up since we are done with these our values here. So here now, say that 2.250 contain well 2.5 grams. So what it means that 250 cm cube is equal to 2.5 grams. Then 1000 cm cube, we need to get what 1 dm cube will contain, which is equal to 1000. So we have 2.5 over 250 times 1000 over 1. This will cancel, that will cancel. So what means if we go down the 2.5 times 100 divided by, we have what we have will be 10 is equal to what? 10 grams. That's 10 grams. So 1000 cm cube contain 1 gram, 10 grams, which is equivalent to what? 1 dm cube per dm cube, 10 grams per dm cube. That's what we can call it. Not very well. This is 10 grams per dm cube. So the next one now says calculate the what? The molar mass. Since this is in dm cube, we know that moles. Okay, we skip something there. We're supposed to finish up with this so that we can solve this problem. Okay, let's go down to that. We'll leave this in here, this one here. Let's go down to the first one. I jump the first to the second. So what we do here is that you remember our value CbVb equal to A over B. So concentration of this in mole per dm cube. This is number 1 question. The other one, I don't know how I jumped to number 2. I don't know what happened. So what we have there is what? This one is what we are looking for. Concentration in mole per dmp is this Ca times volume. The volume is what? 1.11.97 cm cube. That's what we have. Okay, you can leave this one. And then for the base in mole, 0.1 times 25 cm cube, which is the volume of our pipette. Now from this mole ratio, the base is what? 2, the acid is what? 1. So what do? We will cross multiply, then we will have 2 times 11.97 times Ca equal to 0.1 times 25. That will give us here 2.5. Here will give us, the other side will give us 2 times, we'll have 23.94 Ca. So Ca will then be 2.5 divided by 23.94. That will give us 23.94. 2.5 divided by this. We have what we have is, we have 0.104, or perhaps we can make it, okay, let's say, and let's just leave it like this, mole per dm cube. Per dm cube, that's what we have. So the next one we're going to do here, now we'll move over to this. Just look at it very well. That is as simple as how the question is. The question is does not have to be very straightforward. So look at it very well. So let's go over to the next one. The next one, I have already started the number 2 before the time. So we have already stopped at here. So now we have the mole. I can go ahead. Okay, if I'm to go ahead, let's say we can use here. Do you have anything of use here? Okay, let's move over to this side. So we're pushing over this here. Now we know that this is the mole. We have mole equal to mass over what? Molar mass. Molar mass. Now we're calculating the molar mass now from here. Our mole is what? 0.104. Our mass is what? 10 grams. 10 grams is our mass. Note very well. We have 10 grams here all over molar mass, which we don't know. So we'll have to cross multiply. If we cross multiply this, we will have our molar mass to be 0.104 times molar mass. Let me just use mm equal to 10. Then mm, which is our molar mass, will then be 10 over 0.104. So let's see what we get there. 10 divided by. So what we have here is, let me see. Divided by 0. No. 0.10 divided by 0.004. What we have is 96 points what? Let's say 0.2 gram per mole. Gram per mole. So that is what we have. So based on that, what next are we going to do now? This is our molar mass. So we said that we should calculate find the value of x. Find the value of x. To find the value of x, what are we going to do? We know that for the molar mass of this, the molar mass, we have x equal to, so this hydrogen is 1. That means 2 times 1 plus x will give us 96.2. So what do we have? 2 times this plus x will give us 96.2. That means x will then be 96.2 minus 2. We have this will give us, that will give us 94.2. That is the value of the x. The value of the x. 94.2. That's the value of x. So thank you for being part of the class. If you have any question, you can leave it in the comment section. And then I want you to like, share. If today is your first time of joining us, we encourage you to subscribe to our channel for more exciting topics like this. Thank you.